Well, today we will be talking about the topic of naming hydrocarbons. First off, we need to identify the types of hydrocarbons, which are alkanes, only single bonds between carbon atoms, and the general formula of which is CnH2n plus 2. You can refer back to the previous video to understand what CnH2n plus 2 means, and the other general formulas as well. Alkenes contains at least one double bond, and alkynes contain at least one triple bond, where cycloalkanes are alkanes that have bond between each carbon atom, forming a cycle. I wouldn't get into the details of everything in this table right here, but I need you to memorize the prefix of each one from 1 to 10. For example, meth, N for alkane, ethane, then ethene, ethine. So it follows the naming scheme of the group: alkane, alkene, alkyne, ethane, ethene, ethyne. And it goes meth, eth, prop, bute, pent, hex, hept, oct, nona, deca. And the reason we don't have alkenes for single carbon atoms and alkynes for single carbon atoms because you can't have a double bond with only one single atom. And so it goes for the cycloalkanes. Now, how to name complex hydrocarbons? First off, we need to identify the longest chain of carbon atoms. Then we need to identify the hydrocarbon type, whether it is an alkane, alkene, or alkyne, by looking at the bond types. Then we need to identify the number of double or triple bonds, and if there is more than one, we add the prefix di, and if there is three, we add the prefix tri. Then we need to identify branches and their names. Follow the same naming as the alkanes, but end with -thil. So, for example, instead of methane, we go methyl. Instead of ethane, we go ethyl. And instead of propane, we go propyl. And fifth, we go number each carbon atom so that the branches are in the lowest possible number. And you will understand this when we get into the practice and writing the name accordingly. So, first off, we have the chain in front of us. The longest chain of carbon atoms consists of 5 carbon atoms, and we can see we have 2 double bonds between the carbon atoms, which means this is a pentadiene. Since there are no branches, it's written just as is. Now, for this compound, we have 2 branches. So we need to identify the longest chain. The longest chain of atoms is 4 atoms, 4 carbon atoms in a row. And if we go back to the table, 4 atoms is butane. We also have 2 branches located in the second carbon atom, which are CH3 and CH3. Since there is only a single carbon atom, it's methyl. So we have 2 as the position of the branch, then another 2 because there is another branch in the same carbon atom. So it's 2 dimethyl butane, and di here is because we have 2 branches instead of 1. Now, here we have a cycloalkane. The one written on the right is just another form of writing a cycloalkane. In any cycloalkane, the longest chain is the cycle itself. Since we can identify 6 corners, there are 6 carbon atoms, and 2 outside branches, which means there are 2 carbon atoms together. And if we go back to the table, if there are 2 carbon atoms, it's eth, and it's only single bond, which means it's ethyl. So there is a hexane and an ethyl, which means it's an ethyl hexane. We don't write a number when it's only one branch in a cycloalkane.